I gotta do our own theme music because I never know exactly when it's gonna start. Okay, here we go. We're on live. All right, welcome to UAB's Data Science Club. It's been a couple of weeks since the last time that we convened. Just life, conferences, and other such things have gotten in the way. But we're going to pick it back up with the time series analysis tutorial that we were going through last time. So I'm going to post the YouTube link to that in the chat. So if you want to go back and check out what we did, we went through a pretty decent tutorial, and I'm going to post a link that here as well. So it's this data quest tutorial, and yeah. All right, so we've got the data quest tutorial in there. And so if you haven't seen the last video or done the tutorial from the last time, go ahead and check that out and then come back to this one. It's a nice tutorial. I think the big takeaway was that using your date time as your index gives you a lot of subtle but really powerful functionality in Pandas that you don't otherwise get. And basically, if your date time isn't your index, it's a big pain to figure out how to manipulate the date times for plots. But if your date time is your index, it makes your life a lot easier.
Yeah, I mean, most of the things that we discussed and we are going to discuss today, all of those things you can do whether or not you put your date time in as the index for your data frame, but it's just about making your life much harder and achieving the same functionality that you can just achieve by a single line, because Pandas has a lot of inbuilt features that you can use, or a lot of inbuilt functionalities that you might be looking at, which becomes super easy when you have your datetime column as the index column. And we did discuss how you can set your datetime column as the index column when you are actually just loading in your data frame. That's why it would be a good idea to go through the first half of this session as well.
Yeah. Yep, for sure. So the nice thing about this is the only thing we have to have loaded is Pandas. So this is the notebook that we started creating last time. And so rather than going and manually running all of the cells, I'm just going to come up here to where it says cell, and I'm going to say run all. And then, yeah, that should, yep, there we go. Because we're going to continue on the tutorial over here on the left side. And we want to make sure that we've got all the variables in place. All right, so now it's all run and we can go ahead and start. Let's see. All right, so the first thing here that they want to talk about next is this
Seasonality.
seasonality. So we're going to look at box plots because that will group quite a bit of data together and will give us a feeling for the variance of the data in there.
Yeah,
Right,
and I mean, since we are dealing with time series data or date time data over here, then that basically means seasonality. What the word season means, that's what this topic is. It's basically how your data frame keeps changing according to how year progresses, and that's what we are basically seeing over here. uh, at least on the left side column. We need to see what's happening on the right side column.
Yep. Yep. All right. So we ran it and we got this error.
Oh,
Expected an indented block. So one of the nice things about Python is it essentially forces you to format your code, which ends up making it a little bit more readable. Uh, Coding languages like C, C++, leave it up to the programmer to decide how to format your code. As long as you have parentheses in the right place, your for loops and all that will work just fine. In Python, it uses that indent to actually determine what's inside of the for loop. Um, so let's
yeah,
see.
and
I think everything in here is in the for loop.
I think so.
Yeah.
Should be.
Yeah, because basically what we're saying is, okay, so create a figure with axes using this matplotlib subplot. So this says create me 3 subplots, and then share x is saying we want them all to have the same x-axis. And then for name comma ax in zip is saying for name. So it's going to iterate through these first 3 names. So consumption, solar, and wind. And then the axes is going to basically say also iterate through the plots.
Mm-hmm.
Will be the axes part. Um, and so then we're going to make a new plot for each one of those and set the title to the name, and then only label the bottom axis. So let's try to run that now. Yeah. All right. So that's nice.
Yeah, and indentation is like one of the founding principles of Python, that is readability. Your code should be, I mean, those are two very basic things that Python, it seems like when it started, that was their philosophy. The code should be readable and code should be super high level. And it should be super easy to write and super easy to read. And that's why you see that indentation. It just gives you an idea that that's one block of code that's there, and that block of code has its own functionality. So that's the reason why you don't need a lot of semicolons that a lot of other programming languages need to know that a line has ended.
Yep. Yep. Absolutely. All right. So this box plot basically helps us navigate some of the things that were going on in the data earlier. Um, like if we scroll up and look at the solar, wind, and power consumption to see how the power consumption changes over time, uh, it really helps confirm that yes, I use more solar power in the middle of the year. I use less wind power in the middle of the year, um, which makes sense.
Mm-hmm.
All right. And then we can do the same thing to get kind of a seasonality of what's going on by week,
Yeah.
or weekday rather.
Yeah. And I think this entire data set is based on Germany's total energy consumption, I guess, right?
Yeah, I think so. Yeah. All right. So that's seasonality. The other thing that's nice about taking a look at seasonality is it does help differentiate normal variations throughout the year from what you might see due to just uh, the an actual trend of being increasing or decreasing over time. So so if somebody made a graph that said solar usage has declined in 2020 and they just used the second half of this graph, and say, you know, if you look at it from June to December, solar usage has gone down. That wouldn't really be telling us anything because we expect solar usage to go down in the winter months.
Yeah.
And so it's nice to kind of remove some of that variability, or at least be aware of that variability in the data set.
Why do you think we have more consumption during weekdays rather than weekends? Mostly because of businesses
Yeah, I
occupying
think
more?
that's just the overall consumption of the country.
Mm-hmm.
And so I would imagine that um, you have less air conditioners and whatnot running in large business buildings on
Mm.
Saturdays
Weekends.
and Sundays.
Yeah.
It's at least my guess. All right, so now let's look at, so we're going to start looking at frequencies. Let's see what this does for us. Okay. All right, so let's see. So frequency. All right. Okay, so this frequency command can be used to create an evenly spaced frequency throughout this range. Okay.
Yeah, so it
And the
seems
D
like,
flag says, oh, okay, so it's saying the range should start here, end
yeah,
here,
and
and I
it's a
want
day.
yeah, it's a day.
Yeah.
Um, which that makes sense. In Python, you can do range with integers, where it's like range 1 comma 10, and it'll give you 1 2 3 4 5 6 7 8 9 10. But that's harder to do with date times, so this makes sense.
Mm-hmm.
So that's basically the same thing, but with date time. And so we can do the same thing, but with hours. Okay. And then, so let's see. So now, if we see, let's just look again at our index. All right, so what we're noting here is that we actually don't have a specified frequency. So if we're missing a day here, then we just won't have that day,
Mm-hmm.
even though this is a date. But I think this next piece will allow us to specify directly
Yeah,
what the frequency should be.
what if happens if we set it to months or M rather than?
I don't know. So let's see. So okay, so this is pulling out. All right, so that's essentially what this next piece is looking at.
Mm-hmm.
All right, so if we come here and we say, okay, I want to make a time sample that's the 3rd, the 6th, and the 8th. So that's not an even range. And I'm going to copy those dates into a new sample, and then I'm going to print it out. So then I'm just going to get the numbers for those 3 dates.
Mm-hmm.
But if I use the asFreq command, so then I can take the consumer sample as frequency of days, and it's going to create
Missing.
4th and 5th, 7th, yeah, 4th, 5th, and 7th in here. And then we can specify to do a forward fill, and then it will actually populate the missing days with the data from the previous day.
Mm. Interesting.
So let's see. So if we come back up, so your question was, what if we come in here and say OPSD daily we'll just call this copy equals OPST daily dot as freak to try.
Yeah, I think M should be a decent option.
All right, so then if I just look at the, I just look at the index of my copy. Okay. All right.
Yeah. So we have monthly setting over here. Yeah, February is 28 days, or 2006
Yeah.
only had 28 days in February. So that's the last day that it's showing the result for.
Now I'm interested, does it, okay, so it looks like it just pulls the data from that date.
Yeah, I mean, so the data that we have, I think it has results for all the days.
Yeah, the data that we pull in has results for all the days, but when you do the as frequency, I think you can probably specify it to do like an average or something.
Yeah.
But since we didn't, it just takes the data from that date. Yeah, 1107. It's the very last 1107. Yeah. All right.
That's interesting.
Yeah. All right. So now if we keep on going down, we can do resampling. All right. And so this is what we were talking about of we could create a new data frame that didn't just take that data point from that specific day, but also consider the
Averaged out.
data points that we were eliminating. Yeah. So this one averages amount. Okay. And so then if we look at the size of these two data frames, if we go by daily, we have 4,300 days, but weekly we have 627 weeks, which makes sense.
Yeah, yeah. I mean, our data frame, we are just eliminating 6 of the days and just leaving, or we are eliminating 7 and replacing it with 1 entry. So,
Yeah. But again, this is nice because this allows us to, yeah. So we resample it by a week, and then we can more easily see the general trend. So this is kind of like the New York Times COVID dashboard that they have, where they show the 7-day average. So that's essentially what we're doing here, except this is power and not pandemic numbers.
yeah, yeah. I mean, if you look at the daily graph, you'll see that the graph is just constantly going up, down, up, down, up, down, up, down. So you can still see a bit of the trend that the consumption is going higher as the days are progressing, or months are progressing, especially since you are going from winter to summer, so your AC and everything is running high. But it's a little bit more difficult to read it in a daily graph rather than a weekly graph. Weekly graph gives you a much more uh, smooth graph, smoothed out graph.
Yep. Yep. So if we look at the numbers, and then we do the same thing, but instead of by week, we resample by month. And when we do this resample, we're going to add it up. So we'll sum all of the numbers for a month. So we'll look at the total power per month rather than the average power per month. then this next plot plots the monthly consumption at the top in black, and then brings in the wind and solar power when they get started. Oh, name M dates is not defined. Set major locator. All right. I don't know where M dates was supposed to be defined. I'm going to just, oh, it still did it, or it still made the plot. Okay. I guess this M dates was supposed to bring in every single year
And
instead of only allow.
it ran okay this time
Yeah.
without any.
So yeah, so this is a pretty interesting plot because it looks like the power consumption really hasn't changed much in the last 10, 15 years,
Yeah.
but that the percentage of it that's renewable energy has increased. All right.
Which is nice.
So now let's see. So it looks like we're computing a percentage. Yeah. So wind plus solar as a percent of consumption. And so then we can plot that as, and it looks like, oh, in order to do that, we do a resample. I think A is for annual. And so we're adding up by year.
Mm-hmm.
And yep, using the resample command. Okay. So then again, we're just plotting the percent or the fraction of total consumption that is wind and solar. So it looks like in 2017, it made it up above 25%. All right. So this next piece, rolling windows. So how's rolling windows different than the resampling?
So the rolling window is basically like, so today is 15th, right? And I'm plotting data for the last 7 days.
Mm-hmm.
So I'll have an average over here. Then tomorrow is 16th, and I'll have from 16th to
Oh,
past
okay.
7 days.
Yeah.
And then so that's what New York Times is doing, the rolling 7 day.
Yeah. So they're not doing a resample, they're doing a rolling average,
Yeah.
because with the rolling average, you have overlapping windows
Mm-hmm.
of time. I gotcha. That makes sense. It's kind of nice that there's just a function for it.
I know. And that gets me excited about. So we have a video previously where we take the New York Times data set and try to build our own Streamlit
Yep.
app. And I still haven't implemented this rolling window, so this is something that I might just go ahead and do.
Yeah. Now you just know it's just a single line.
Yeah.
All right. So once we have the rolling windows, we can plot it, and this is fun. So we're plotting. The green line is the rolling, and so you can see that it still captures more of the immediate variability than the weekly average does, or it's at least smoother. I don't know that it
Mhm.
captures more, but it doesn't suffer from these rapid spikes.
Yeah, I think you are right. It does capture a bit more of how the patterns are changing, and it's not as I mean, the weekly one is really, really smooth. And so you might miss out on some intricate details. I think rolling window gives us a nice combination of both of them, of both daily and the weekly mean resampled
Yeah.
data set.
Yeah, absolutely. All right. So it looks like this next one is we're creating a rolling window over a year, which seems really big.
Yeah, unless and until you are started your counting from 50, 60 years ago.
Yeah. Yeah. Um, but yeah, I mean I guess 15 years is a nice
Yeah.
window with which to do that with. Um, again, the M dates thing, let's just take that out. So, but this should also help in looking at, rather than looking at the seasonal change, this will help look at primarily just the overall trend,
Mm-hmm.
which basically there is none with the total consumption.
Yeah.
Which, I
It's
mean, that's, at least for this data set, that's kind of encouraging, I guess, is that you're not using more power than you have in
yeah.
previous years, which is kind of surprising.
Yeah. I mean, yeah, it has its ups and downs. I mean, economically, increasing power consumption also means more productivity and stuff. So
Yeah,
it totally depends. But I'm guessing Germany always used a lot of power, so
yeah,
already used a lot.
yeah, yeah. All right. So now I'm going to plot. So this is the 365 rolling mean, and I'm going to go ahead and comment out that M dates thing. Um, so this is the 365 rolling day mean, but we're also adding in the solar and the solar plus wind data in there. All right. So yeah, so this is nice because it really shows the trend. It looks like if we look at this,
hmm
solar hasn't really picked up that much,
Yeah.
at least not compared to wind.
Oh, yeah, wind has really, really picked up. I mean, it's also the area, I believe. I mean, we
Yeah,
have we
Germany is
have
kind of more like Chicago in its
yeah.
climate. So
Yeah, I think you need more like Arizona to utilize more solar power, I guess.
yeah, I think so. Oh, and that is the final thing on here. All right. Well, yeah, I mean, certainly you're welcome to join Data Quest, or at least look at their other tutorials. They've got a lot of nice things on there.
Yeah,
Um,
I can't recommend this tutorial highly enough. This would be super helpful to everyone who is watching. Definitely try this out. I think it's going to make your life a lot easier when you actually come across some data set which has time series defined in it, which a lot of data set would. So
yeah, yeah, no, absolutely. I would say this fits in the category of things that everyone should know,
mhm.
and the people that already know it probably just assume that it's common knowledge, so it's not widely spread around when you're learning this stuff. Um, so yeah, I'm with you there. Well, yeah, I think that's it for us for today. So until next time, happy coding and data science playing, and we will talk to you guys later.
Yeah, talk to you guys later.